NASA contacted me about 3 years ago and said they had an interesting project. Didn't tell me much about it, but that there was a lot of past data to analyze to try and figure out what was going on with the polar vortex. So that immediately perked my interest when they mentioned the polar vortex. So I said, tell me more. And so they did, and I jumped right on.
So how's it looking, Elizabeth?
It looks terrific. Strong westerly, northwesterlies all the way up. In fact, the guys are calling in on the radio saying it looks great. Here's one of them right now. They're getting 10 knots right up here. Here comes the radio. On up a big bend, so it looks great.
What is the polar vortex?
The polar vortex, it occurs in the respective winter times in the poles. So, for example, down here in New Zealand, it's wintertime, and the polar vortex is quite active at the moment. And it is caused by the differential heating, of course, in the wintertime down here. It's quite cold over the poles and quite warm over the equator, and you get this differential heating. And then with the circulation of the planet, it causes this high altitude, kind of like a river of air, a circulation of strong cyclonic circulation over the poles. And it has a life cycle of its own. Every year it's a little different. Every year it starts up at a different time. And sometimes it can die right out, especially in the northern hemisphere. It's not as uniform in the northern hemisphere. And one day it'll be there, and the next week it'll be gone when it dies out. Here in the southern hemisphere, it tends to die out more gracefully. But every year we don't know when it's going to form, how long it's going to last, and when it's going to die out.
When did science first come to understand or realize that the vortex existed?
Well, like I say, that was about in the 80s when they were looking into the ozone hole, and they started taking measurements and realizing, wow, this stratosphere that we thought was so quiet, turns out, gee, we have over 260 knot winds up here. What's going on? And we started looking at it and realized this thing is up there and kind of has a life of its own. And we really don't understand it that well right now, and that's what's so interesting about this project, is that we are going to be going up into uncharted territory. We send balloons up, and we do have planes that fly around, but the sailplane will be flying through this quite slowly and for quite a long period of time, 6 to 9 hours. So it's a nice sampling machine for atmospheric scientists.
And what influence does it have on the rest of the hemisphere's weather in the north and in the northern hemisphere and the southern hemisphere, these vortexes? What role does it play?
Well, we're still learning about the role it plays, but it has an influence actually on all the climate, and we think it has an influence in terms of friction and gravity on the whole atmosphere, and so that would then affect climate. And so that's another thing we're looking into, but we don't have the answers to that right now. Well, it's actually not quite as quiet and calm as we think in the stratosphere. One thing is these mountain waves, as they go on up into the stratosphere, they get quite steep. And if you think about a wave coming into the beach, as they get steeper and steeper and steeper, they eventually do break. Not always, but so we do sometimes expect to see some breaking waves, and that can cause quite a bit of turbulence, just as it does a wave breaking on the beach. So some fascinating things going on up there, not just blue sky.
So as a scientist going to a new field, how are you feeling at the moment?
It's fantastic because we're charting unknown territory, and that's every scientist's dream, is to find out about the unknown. So every day the data we get is going to be new and unique and of interest not just to me but other scientists.
You made the call to lie, except to